Welcome to the session on vectors, Introduction to Vectors. The objectives for this session are to be able to use vectors in 2 dimensions. A vector has both magnitude and direction. It can be represented using a directed line segment, as shown. Vector PQ with an arrow above starts at P and finishes at Q. And vector QP with an arrow above it starts at Q and finishes at P, as shown. Let's now take a look at some more vector notation. The direction of the arrow in PQ shows the direction of the vector. In print, bold letters are used to represent vectors. So, for example, the red A highlighted in bold. It will look something like this. In writing, vectors are underlined, as shown. Now let's take a look at equal or opposite vectors. If PQ equals RS, the line segments PQ and RS are equal in length and parallel, as shown. And now if AB equals minus BA, then AB is equal in length, parallel, and opposite in direction to BA, as shown here. Let's now take a look at the triangle law for vector addition. AB plus BC equals AC. If AB equals A, and BC equals B, and AC equals C, then A plus B equals C. Let's take a look at some notation. The resultant is the vector sum of 2 or more vectors. So PQ plus QR plus RS plus ST equals P to T, or PT. So here's PQ, QR, RS, and ST. And of course the resultant is PT, as shown. Let's take a look at an example. The diagram shows vectors A, B, and C. Draw a diagram to illustrate the vector addition A plus B plus C. So let's solve this. Here's A, and here's B. Here's A plus B, as shown. Applying the triangle law to A and B gives A plus B, as shown. And let's now plug in C as well. C, of course, is going to start where B finished. And so the red line denotes the vector A plus B plus C. We've applied the triangle law to A plus B and C to give A plus B plus C, as shown. How do we subtract vectors? Subtracting a vector is the same as adding a negative vector. So A minus B equals A plus minus B. So if we have vectors A and B as shown, then A plus minus B looks something like the diagram shown towards the bottom of your screen, with B simply going in the opposite direction. And the vector line in red denotes A plus minus B. So to subtract B, simply reverse the direction of B and then add. Traveling from P to Q, then back from Q to P, gets back to where you started, and the displacement is 0. Adding vectors PQ and QP gives a 0 vector. So PQ plus QP equals 0. And now PQ equals minus QP implies PQ plus QP equals PQ minus PQ, which is of course 0 again. So we're saying the same thing in different ways. Now let's take a look at multiplying vectors by a scalar. A vector can be multiplied by a scalar or number. A vector parallel to a vector A may be written as lambda A, where lambda does not equal 0 and lambda is a scalar. Suppose lambda is a positive scalar and lambda does not equal 1. Then we have a different length but the same direction. So here's 2A, double the length but the same direction. And here's half A, so half the length but the same direction again. But what if we have a negative scalar, lambda? Suppose lambda is negative. Then we may have a different length, depending on whether lambda is equal to minus 1 or not, and the vector will go in the opposite direction. So here's minus A. Notice that the length is the same, because lambda equals minus 1. However, the direction, as you can see, has changed. And here's minus a half A. The size of the vector A has halved, and it's going in the opposite direction also. Here's a summary. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. So let's have a go at example 2a first. In the diagram, we're required to find, in terms of a, b, c and d, the vector t, q. Here's the journey. To get from t to q, we first go t to p, then p to q. This is the same as saying we have to go in the minus d direction from t plus a, as shown. So we have a resultant vector tq equals a minus d. And now for part B. We are required to find, in terms of a, b, c and d, the vector pr. The diagram has been highlighted with p, q and r in red. Here's our journey. Here's p to q and here's q to r. And in vectors, this is a, where pq equals a, plus b, where qr equals b. So our resultant vector is a plus b. And now for part C. In the diagram, find, in terms of a, b, c and d, the vector st. So here's our journey. In order to get from S to T, we travel as shown. So S to R, followed by R to Q, followed by Q to P, followed by P to T, as shown. S to R is equal to minus C. R to Q is equal to minus B. Q to P is equal to minus A. And finally, P to T is equal to D, as shown. So our resultant vector is D minus A minus B minus C to denote the journey ST. And now for part D. In the diagram, find in terms of A, B, C and D the vector RT. Here's the journey highlighted. So to get from R to T, we first go from R to Q, then Q to P, and then P to T. RQ is equal to minus B, QP is equal to minus A, and PT is equal to D. So our resultant vector is D minus B minus A, denoting the journey RT. And here's a summary of our results. Now take a look at example 3. Pause the video and have a go. Press play when you're ready to view the solutions. So in the diagram, OACB is a parallelogram. M, Q, N and P are the midpoints of OA, AC, BC and OB respectively. Vectors P and M are equal to OP and OM respectively. We are required to express MQ in terms of P and M. So let's solve this. MQ is MD plus DQ. Now MD is equal to P, as shown, and DQ is equal to M, as shown. So MQ is equal to P plus M. And now for example 4. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to show that the vectors 10a plus 12b and 25a plus 30b are parallel. Now let's put one vector in terms of the other. 10a plus 12b can be expressed as 2/5 of the other vector. As shown. And therefore, we can conclude that the vectors are parallel. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So example 5 states, in triangle ABC, AB equals A, AC equals B, P is the midpoint of AB, and Q is the midpoint of AC. We are required to write in terms of A and B the vectors shown on your screen. So let's solve example 5a first. The vector BC is equal to BA plus AC. Now BA is equal to minus A, since AB equals A, and AC is equal to B. So vector BC is equal to B minus A. Now let's solve example 5b. The vector AP is equal to half AB, as shown. This in turn is equal to half A, since AB equals A. Now let's have a go at example 5c. We are required to find the vector AQ. So let's solve this. AQ equals a half AC. And since AC equals B, we have that half AC equals half B. And now for example 5D. Let's solve this. So vector PQ is equal to PA plus AQ. This in turn is equal to a half of BA plus a half of AC. Now since AB equals A, we have that BA equals minus A, and therefore half BA equals minus a half A, as shown. And since AC equals B, we have that half AC equals half B. And so our resultant vector is a half B minus A, as shown. And here's a summary of our results. This brings us to the end of this session. If you have understood its contents, you should be able to use vectors in 2 dimensions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.